Now we have studied right angle trigonometry and then non-right angle trigonometry. And now we will start with the past paper questions related to non-right angle trigonometry. Now, usually non-right angle trigonometry questions, 99% of the time, they are related with paper 2. So let's get started. Now the exercise is on page 25, and by mistake, it's written that it is a paper 1 question. In reality, it's a paper 2 question on page 25. That's the whole exercise. Now let's look at the first question. The question says, the diagram shows a footpath PR across a park PQRS. So this is PQ and this is QR. This is RS, and then this one is the purple one is used, and let me use the blue one that is over here, which is PS. Now 4 lengths are given, and then one length that joins the two, that is right over here. Now it's all these angles and all these lengths are given. Calculate QPR. Now first of all, if I'm interested in QPR, I'm interested in this angle. I have 1, 2, 3 sides are given. I'm finding the angle that is opposite to 91. So I'll be using cosine rule. So first decide on the strategy. So the strategy is, you have how many sides, how many angles, is it included, is it opposite? So we have 3 sides, and we are looking for a particular angle, and that angle is QPR. So QPR is opposite 91. So let me write it this way. So for part A, 91 square equals to 64 and 53. That is 64 square plus 53 square minus 2 into 64 into 53 into cosine of this angle QPR. Now, my habit is that I won't learn a formula. I would rather learn the basic idea and then make it the subject. Second thing, that is, let me highlight the important detail. That is, first simplify as much as possible and then use calculator. So do not use calculator at the very beginning. Why? Because you will be losing out on the accuracy. 91 square minus 64 square minus 53 square divided by negative 2 into 64 into 53. That equals to cosine of QPR. So now, using a calculator, you will evaluate it. And if these two negatives, this negative and the overall, I think so, it will be a negative sign. Or maybe it's positive, I'm not sure. Why don't you go ahead and use the calculator? Give me the numerator separately and give me the denominator separately. The denominator is definitely negative. So write the answer in the WhatsApp group. I'll wait for it. Two into 64 into 53, that is 6784. So this is 6784 with a negative sign. That's the denominator. What's the numerator? Okay, people, I'm waiting. 1376. It's positive or negative? 1376. It's positive. So now this equals to cosine of QPR. So let's divide 1376 divided by 6784. This comes out to be negative 0.2028 equals to cosine of QPR. Therefore, QPR equals to, let me write it properly. So this is Q, this is P, this is R, is cosine inverse of negative 0.2028. So my calculator, let me change it into the degree mode and shift and sine. So second and sine, and this comes out to be 11 point, that's negative, I forgot. So therefore, let me press cosine, shift, hold for a second. That is 0.2028. It doesn't have a negative sign, my bad. So 11.7, so 180 minus 11.7. I think the answer is 168.3. This is 168.3. Let's double check. So now this is the answer that I've gotten from you. So this is question number 2, the first part. So let me go over here. This is the exercise. This is question number 2. That is this one. I think I made a mistake or something. If the working is perfectly good, this is 101.65. So let me write it down. So this is 101.65. Just double check this. So this is 101.65. And that makes sense because the diagram, even though it's not drawn to scale, it is never misleading. So it is something greater than 90. So the answer makes sense. So the first part is done. Now let me add a page. Let me take this diagram again. And let me solve for the other parts. Okay. Now this thing is done. Then we are interested in RPS. RPS. That is this one. RPS, this angle. Now let me highlight it. So this is opposite this side, which we don't know. And then 74 is opposite 68, that we know. And the third one is that 53 is opposite this angle. So therefore, we cannot find RPS. We have to find PSR first. So first, find PSR using sine rule. So that is the strategy. So therefore, sine of PSR over 53. Sine of PSR over 53 degrees, 53, that's a distance. That's the same thing as sine of 68 over 74. Sine of 68 degrees over 74. Again, first simplify. Sine of PSR equals to 53 sine 68 degrees divided by 53 into this divided by 74. Now let me grab the calculator. So now this is sine of 68 using the sine button, multiplying with 53, dividing by 74. This comes out to be 0.6641. This is 0.6641. This is sine of PSR. Therefore, make PSR the subject. That is sine inverse of 0.6641. So shift and then sine. This comes out to be PSR is 41.61. So I'm giving the answer correct to 1 decimal place. Let's also check this answer. So this answer is over here, 41.55, 41.65. I have rounded it off. But now this is 41.61. I should not round it off. Hold for a second, because I'm not just interested in finding this. This is 41.61. And then we are interested in this angle, that is this green angle over here. So therefore, this plus this subtracted from 180. So SPR or RPS plus 41.61 plus 68 equals to 180. Therefore, let me add to it 68, and then subtract it from 180. That comes out to be 70.39. So RPS is equals to 70.39. Therefore, this can be written as 70.4 degrees. Now let's double check the answer. So yes, it's right over here, 70.35, 70.45. That is the answer. Now let's look at the third part. The third part is the area of triangle PRS. So now PRS. In order to find this area, I need two sides and an included angle, that is this angle. So let me solve on the same page. So let me just make a box over here. And then I'll write that part C, area of triangle is half AB sine of C. So we have 53 and 74. That is half of 53 and 74 and sine of this value. So sine of this value is sine of 70.39, use unrounded value. Sine of 70.39. So let me multiply it. So 70.39. So that is, let me just double check. That is 70, or yeah, 70.39. So therefore we have 70.39. Take the sine, multiply with 0.5, multiply it with 53 and 74. So this comes out to be 1847.26. Let me correct to three significant figures. 1850. This is meter square, and this is given correct to three significant figures. Also, let's double check the answer right away. So that is 1845 to 1855, and our answer is perfectly good, perfectly correct. So that is how this particular question related with sine rule, cosine rule, and the area formula is done. Now, I'll pause the recording and I would ask you to try out this. So now this is what you need to try out. This is the first part. And then this is the second part. It's a little bit about scale drawing also. So I'll just pause the recording and then you can try it out. Now let's look at the first part. The first part says ABC is a triangle in which ABC equals to 34. So this angle is 34, AC is 15, BCD is a straight line, this angle is 60 degrees. Therefore, first of all, this angle is 120 degrees. Therefore, this angle over here, that would add up to this, and this should add up to 60. So 60 minus 34, that is 26 degrees. Always a good idea to double check. 30 plus 20, 50. 4 plus 6, 10. That is 60. 60 plus 120, 180. First of all, it's asking for BAC. So BAC is found. That is 26 degrees. The next one is finding BC. Now, in order to find BC, let me draw this line BC. This is opposite to this angle over here. And then this length 15, this is opposite to this angle, which is 34. So let me write it out. So therefore, we will write sine of 34 divided by 15 is equals to sine of 26 divided by BC. So I'll just make BC the subject. BC equals to 15 sine 26 divided by sine of 34. And let me grab the calculator. Sine 26 multiplying with 15. This is 6.5755. 6.5755. And what about sine of 34? 34 and then sine. That's 0.5592. 0.5592. 15 sine 26. 15 and sine, okay, sine 34. This is 34 in front of 15 and 26 in front of BC. So BC is 15 sine 26 divided by sine 34. Okay, that makes sense. And multiplying it with 6.5755, 6.5755, this comes out to be 11. So this is 11.76. This is BC. Therefore, BC can be written as 11.8, and the unit is centimeters. So this is centimeters given to 3 significant figures. This is 6 part A. Let me go to the answer. Let me open it up to 6 part A. That is, this thing is 26 and 11.8, perfectly correct. Now, let me move on to this part. Now the question says, the shaded part of the diagram shows a lake. Now, not just this line, this whole shaded part, that is a lake. P and Q are points at each end of the lake. So this is one end, this is the other. R is a point on the same level as P and Q. The distances and the angles are given. Calculate PQ. So now we have two sides and an included angle. So this is one side, this is the other side, and this is the included angle. That is this green one over here. So when you have two sides and included angle, you can find the third side, that is over here, that is using cosine rule. So again, I'll solve it out. That's for 4 marks. So first of all, I'll write PQ, the whole thing square, equals to, let me make it thinner, that is 55 square plus 70 square minus 2 into 55 into 70 into cosine of 112 degrees. So let me first simplify what's on the inside the bracket. So therefore, we have 112. We are taking the cosine, that's a negative value. So remember, cosine of an obtuse angle is negative. This negative will make it positive. So therefore, this value multiplying with 2, multiplying with 55, multiplying with 70, this comes out to be 2884.47. 2884.47. Now, what about 55 square? That is 3025. So 55 square is 3025. What is 70 square? That is 4900. And all this will add up to PQ square. So let's add it up. So that is 3025 plus 4900 plus 2884.47. This comes out to be a 10809.47. Therefore, let's make PQ the subject. Let's take the square root of this, and that comes out to be 103.96. 103.96, which can be written as 104, and the unit is what? That's meters, correct to 3 significant figures. So that is the answer for this part. Again, just double check right away. That is 104, all good. That's the one. Now let's move on. It says a plan is used, a plan is drawn using a scale of 1 centimeter to 5 meter. State the length of PR and QR on the plan. So this is basic scaling. So if this is scaling, I'll write, this is actual, right? So first of all, let me write actual and then the plan. The actual is in which units? That is meters. Plan is in centimeters. So therefore, 5 meter is 1 centimeter. You're scaling it down 5 times. And what is PR? PR is 55. So 55 meter will become 11 centimeter. And what about QR? QR is 70 meter. That will also be divided by 5. So that would be 14 centimeter. So now these two values were written over there. That thing is done. Now the next part. Find the area of the triangle on the plan. That means we have to use this, and the angle will remain the same. The angle will be unchanged. So therefore, if we talk about 2, and this is part B, so this is area on the plan. So this is half into the area of PQR. This is half into 11 into 14 into sine of 112 degrees. So therefore, 112, taking the sine, multiplying with 11, multiplying with 14, multiplying with 0.5, that comes out to be 71.393. That comes out to be 71.4, and this is centimeter square because this is on the plan. Now, what about the last part? For the last part, it says the area of the lake on the plan is 34 centimeters square. So now this is not the lake, this is not the triangle, this is the lake over here. Calculate the actual area in square meters of the lake. This is again about scaling. So part C, I'll write actual, I'll write plan. When we talk about length, we say that 5 meters equals to 1 centimeter. When we talk about area, we square both sides. So this will become 5 into 5. That is 5 square meter, 5 square meter square, and this will be 1 square centimeter square. So therefore, this is 25 meters square is 1 centimeter square. And we have 32.4 centimeters square. So this is 5 meter is 1 centimeter. Okay. 32.4 centimeters square, and let this be x. So if I cross multiply, therefore I'll multiply it like this and multiply it like this. So x into 1 is 25 into 32.4. So 25 into 32.4, that comes out to be 810. And what is the unit? Meter square. So now let's double check. This is 810, this is 71.4, this is 11, and this is 14. So over here we have 11, 14, 71.4, and 810. So this is all got all correct. Okay, now, so this question is done. Now I would like you to solve out this question, again sending you the image on WhatsApp. Till then, I'm just pausing the recording. So now we are starting with this. The question says, in the diagram, AC is 11 and BC is 5.5, BAC is 25. It is given that ABC is an obtuse angle. Now, why does it say that? It's a very small conceptual question. There is this side, there is the red side, and then there is the green side. And it says ABC, this angle over here, that's an obtuse angle. Now, calculate ABC. First of all, I'll write sine of ABC divided by 11 equals to sine of 25 degrees divided by 5.5. Therefore, make sine of ABC the subject. That is 11 sine 25 degrees divided by 5.5. So let me grab my calculator. And over here, I need to evaluate 2 multiplying with 25. This is sine into 2. This comes out to be 0.8452. This is sine of ABC. Therefore, ABC is sine inverse of 0.8452. Now the calculator will give me this answer, ABC, as 57.69. Now you should remember a rule that related two things together. That is, sine of 180 minus theta is the same thing as sine theta. And yes, there was another one also, but that's not in context right now. That is cos of 180 minus theta is negative cos theta. That means sine of 150 degrees is the same thing as sine of 30 degrees. That means sine of 120 degrees is the same thing as sine of 60 degrees. That means if theta is 30, 180 minus 30 is 150. If theta is 60, 180 minus 30 is 120. That means this value over here, this is sine of 57.69. That is the same thing as sine of 180 minus 57.69. It will have the same value. So subtract 180, and this angle comes out to be 122.30. That is the answer for this particular part. This is question number 8, 122.3. I'll write it down. Correct to 1 decimal place. So this is question 8, the first part. So over here, it's question 8, first part, 122 degrees. Okay, let's get started with the second part. Now it says in the diagram, DF is 12, DE is X, and EF is 5 plus X. Form an equation in X and show that it reduces to this. So now the previous question was an application of cosine rule, sine rule, and this one will be an application of sine rule. So remember this thing, and of course you can get it from the calculator. That is cosine of 120 degrees is negative 0.5. I've already written down this value. Now we have two sides. We have the included angle. We can find the third side. So we will write 12 square is equals to x square, 5 plus x inside the bracket whole square, minus inside the bracket 2 into x into 5 plus x into negative half. Actually, this is cos of 120 degrees. Now, cosine of 120 degrees is negative half. This negative half, this negative, this 2, this will multiply. So that will make it positive 1. So this is x square. This is 25 plus 10x plus x square. And then this negative has become a positive. This is x into 5 plus x. That is 5x plus x square. Now let's add the like terms together. There is x squared, there is x squared, there is x squared. So therefore this is 3x squared. There is 10x, there is 5x, that is 15x. And then there is this 25, and that's the only constant. Plus 25, this equals to 144. So therefore, let me write a 0 over here. This is 3x squared, this is 15x. And the difference between 144 and 25, that is 119. So this is negative 119. Let me double check. 3, 15, negative 119 equals to 0. So I have done the first part correctly. Is this all good? All clear? This is B part 1. So now the first part is done comfortably. Let's focus on the second part. The second part says solve the equation giving each answer correct to 3 decimal places. So this is the usage of quadratic formula. So we will write ax squared plus bx plus c equals to 0. Therefore, a is 3, b is 15, c is negative 119. Let me first evaluate b squared minus 4ac for the quadratic formula. So this is 15 squared minus 4 into 3 into negative 119. So now, again, be careful of all these things. These two negative will become positive. So therefore, this is 12 into 119. This comes out to be, let me just, so this is this thing. So 12 into 119 is 1428, and 15 square is 225. That is 225. So therefore, 1653. And let me write the formula. X is equals to minus b plus minus b square minus 4ac square root divided by 2 times a. So therefore, this is minus 15 plus minus square root of 1653 divided by 2 times 3. This is minus 15 plus minus. Let's take the square root, that is 40.66. So use 4 significant figure value, 40.66 divided by 6. So now there are 2 answers. Therefore, x is equals to negative 15 plus 40.66 divided by 6. And we have x is equals to, let me add a page over here. So I'll be needing that. So x is equals to minus 15 minus 40.66 divided by 6. So first of all, this is 40.66 minus 15. You get this answer, divide by 6. Therefore, this x comes out to be positive 4.276. And this x is negative. It's 15 plus 40.66 divided by 6. That is negative 9.276. This is one answer. This is the other answer. Giving each answer, they're asking for both the answers, the positive value and the negative value. But what about the next part? The next part says, find the length EF in millimeters correct to the nearest millimeter. Now, this thing is in centimeters, okay? And what is EF? EF is 5 plus x. So we are interested in EF. So therefore, EF part 3, that is 5 plus x. We have to use the positive value for length. So length cannot be negative. It has to be positive. That is 5 plus 4.276. That is 9.276 centimeter. Multiply it with 10, 92.76 centimeter. And the answer is asked for nearest millimeter. Now, I've already multiplied by 10, so therefore this is millimeter. And that is this 7 will make this 2 as 3. So that is 93 millimeter. That's the answer. So let's all double check. And from the answer, over here, 4.276, 9.276, negative 93. This is all good, all correct. So this answer is done. Okay. Now let's look at this question. Looks slightly difficult, but it's not related to a quadratic. And again, I'm sending you this by WhatsApp. Try it out for around 7-8 minutes easily, and then I'll explain it. Now, if we look at this question, it says ABD and ACE are straight lines. So ABD and ACE are straight lines. BD is 12. So this much is 12. CE is 4. CE is 4. AB is x. And AC is 2x minus 5. So let me label it in 4 colors so we can visually see what exactly is happening. First color, second color, the third color, and the fourth color. Now it says angle BAC is theta. The first part, show that the area of triangle ABC is this one, divided by area of triangle ADE, that is this one, is this much into this much. Now they have worked in this format, AB, AD, AC, AE, something like that. Now, first of all, area of triangle ABE, that is this one, ABC, that is half AB into AC into sine of theta. 2 sides, included angle, AB, AC. I'm not putting in the variables yet, just like that. Similarly, area of triangle ADE, that is half into AD into AE into sine of theta. Again, double check this and the same angle. Now, when I divide this half and this half cancels out, this sine theta cancels out. What am I left with? AB, AC. This is AB, this is AC. This is AD, this is AE. That is the ratio that we are talking about. So that is for the first part. The second part, it is given that area of triangle ABC, area of triangle ADE, the same ratio is 1:3. Use the result from part A, form an equation in X, and show that it simplifies to this. Now we know that for part B, AB, AC divided by AD, AE. This equals to this ratio, which is 1/3. Now, what is AB? AB is X and BD is, and AD is X plus 12. So AB, AD. AB, X, and this is X plus 12. And AC is 2x minus 5 and 2x minus 5 plus 4. So this is 2x minus 5 and 2x minus 5 plus 4. Just double check. This one, the first one, the red one, is AB. So this is AB. And then AD is AB plus this thing. So that is the red plus the blue. So that is red plus the blue. This is red and this is the blue. What else is there? There is the green and then green purple plus purple, AC and AE. So this is green and this is green plus the purple. This equals to what? This equals to 1/3. So just simplify. This is X. This is 2x minus 5. Over here, this is X plus 12. And this is 2x minus 1. Is equals to 1/3. Cross multiply 3x, 2x minus 5. This is 1, x plus 12, 2x minus 1. This is 6x squared minus 15x. This is 2x squared minus x plus 24x minus 12. Transfer everything to one side. 6x squared minus 2x squared, that is 4x squared. Negative 15x, negative x goes on the other side, 24 goes on the other side. So that is plus 23. So negative 15, negative 23 is negative 38. And then we have this negative 12, take it to the other side, that becomes positive 12, and we are equating it to 0. Let's double check. 2, negative 19, and 6. So let's divide by 2. 2, negative 19, plus 6 equals to 0. So we got it all right. That was simple, but in a very different way, they have formed this equation. And then it's about solving this out. So that is again using the quadratic formula. See part 1. 2x squared minus 19x plus 6 equals to 0. Let me write underneath it ax squared plus bx plus c equals to 0. A is 2, b is negative 19, c is positive 6. Let me evaluate b squared minus 4ac. That is negative 19 whole square minus 4 into 2 into 6. And let me simplify this. That is 19 into 19. That is 361. And 4 into 2 into 6. 4 to the 8, 8 6 are 48. So this is 361 minus 48. This comes out to be 330. Let me also take the square root of 313. That is 17.69. This is the square root. So now let me write it over here. Therefore, x is equals to minus b plus minus b square minus 4ac, the whole thing square root over 2a. So this is minus 19 plus minus square root of 313 divided by 2 times 2. This is positive 19 plus minus, let's write this value, 17.69. Remember the rule, work in 4 significant figures. divided by 2 into 2 is 4. Now there are two options, either this or this. 19 plus 17.69 divided by 4, 19 minus 17.69 divided by 4. Now this time both are coming to be positive. So first of all, 19 plus 17, hold for a second, 19 plus 17.69 divided by 4, that is 9.1725. And 19 minus 17.69 divided by 4, that is positive 0.3275. So these are the two values that we will get. Over here, in this case, both are positive. State, that's a good question that they're asking. State with a reason which of these solution does not apply to triangle ABC. Now let's look at this. This is over here. This is x, this is 12, this is 2x minus 5, this is 4. Now x could be a decimal positive value, that's not an issue, but what about this 2x minus 5? So if we talk about 2x minus 5, let me write it over here. So this is C part 2. So that is C part 1. This is C part 2. If we talk about 2x minus 5, that is 2 into 0.3275 minus 5, we can see that this is negative value, and we know that length, dimension cannot be negative. Therefore, we have to discard this value and we have to accept this value. Discard or reject, you can use either term. So that is the answer. Given that theta equals to 25 degrees, calculate BC. So BC is this line over here. Let me highlight this. That's the orange one. So we have two sides. This is x. This is 2x minus 5. Angle is theta. So let me continue over here. We have two lengths. We have a length that is x. We have a length which is 2x minus 5. We have theta. Theta is 25 degrees. X, we have to take it to be 9.1725. And 2 into 9.1725 into 2. And then we are subtracting 5. This is 13.345. 13.345. Therefore, in order to find the length that we are looking for, which is BC, we are applying cosine rule. So BC square is 9.1725 whole square, and this is 13.345 whole square, minus 2 into 9.1725 into 13.345 into cosine of 25 degrees. And now it's just using a calculator. Remember, this value will be BC square. Therefore, BC will be the square root of that. So that was nothing special over here. The main thing was this concept of using the formula and then simplifying things and solving a quadratic related to it. So that completes the concept of non-right angle triangles.